So, what happens when your app goes viral overnight? I mean, it's every developer's dream, right? But believe it or not, it can also be their biggest nightmare. Today, we're going to break down the core concepts of cloud computing by following that exact story, from a single server that's about to crash to a global, unstoppable system. All right, picture this. You wake up one morning and your app is number one. It's everywhere. Traffic is just exploding. This is it. This is the dream. But for that one little server running your app in a closet somewhere, this dream is turning into a nightmare fast. That massive sudden spike in users, it's about to bring the whole thing crashing down. And that right there, that's the fundamental problem that modern cloud computing was built to solve. It's not just about, storing files. It's about handling success. How do you seamlessly manage that crazy, unpredictable growth without your users ever seeing a single error page? Well, back in the old days, the answer was something called vertical scaling. If you needed more power, you just bought a bigger, beefier, and way more expensive server. But there's a huge problem with that. Not only does the cost get a little crazy, like doubling the power costs way more than double the price, but you've also created a single point of failure. If that one giant server goes down, your entire app is just gone. So the cloud takes a totally different approach: horizontal scaling. Instead of one giant expensive machine, you use a whole fleet of smaller, cheaper ones all working together. And this gives you incredible stability. If one server fails, no big deal. The others are still there to pick up the slack. It's way more stable, it's more cost-effective, and honestly, it's the bedrock of how the entire modern cloud operates. Okay, so we're taming the traffic. Now that we have this whole fleet of servers, we've got a brand new challenge. How do we manage them? You have to intelligently distribute all of that incoming user traffic, right? You can't just have people picking a server at random. And this is where the load balancer comes in. It's perfect. Think of it like an air traffic controller, or maybe a traffic cop for your application. It sits right at the front gate, takes every single user request that comes in, and smartly directs it to a server that's healthy and ready to handle it. It automatically skips any server that's down or overloaded. It's what makes the user experience feel fast and smooth, no matter what. And it's not just random either. A load balancer uses some pretty clever strategies. You've got the simple way, round robin, which just deals out requests one by one, like playing cards. But then there are smarter methods, like sending new traffic to the server that has the fewest active connections, or the one with the most free processing power. This makes sure your resources are being used as efficiently as possible. Now, this is where the real magic happens: auto-scaling. Instead of you frantically adding more servers by hand when traffic spikes, this system just does it for you. It's constantly monitoring the load. The second it sees a huge rush of users, bam, it automatically launches brand new servers to handle it. And just as importantly, when the rush is over, it shuts those extra servers down so you're not paying for what you don't need. It is, without a doubt, the cloud's superpower. So we've scaled up our servers, but the smartest applications also change how they're built from the inside. It's all about working smarter, not just bigger. The traditional way to build an app was kind of like a tightly wound ball of string. When a customer places an order, the order service has to directly call the payment service, which then has to turn around and call the shipping service. They're all tightly coupled. So if one part of that chain is slow or broken, the whole thing can grind to a halt. Now let's compare that to an event-driven architecture. Instead of services calling each other directly, the order service doesn't call anyone. It just publishes an event, basically a message, to a central hub. Think of it like dropping a letter in a post office box. It just announces, hey, an order was placed, and then it moves on. This creates a really simple but incredibly powerful model we call pub-sub. The publisher is the service that creates the event, like our order service, and the subscribers are any other services that care about that event. So the shipping team, the fraud team, the analytics team, they can all independently pick up that order-placed message and do their work without ever needing to know the other services even exist. It's just beautifully decoupled. Okay, so we have a scalable architecture. Awesome. But how do we get new code from a developer's laptop into this complex environment, reliably and without breaking everything in the process? Yes, the classic phrase, the one that has echoed through development teams for decades. This is what happens when a developer's laptop is set up differently than the production servers, causing code that worked perfectly in testing to just fail spectacularly in the real world. Containers are the solution here. They package an application and all of its dependencies into a single, neat little box that runs the exact same way everywhere. But then you have a new problem. How do you manage thousands of these containers at scale? Well, that's where container orchestration comes in. It's the system that automates everything for you, deploying containers, replacing them if they fail, and scaling them up or down as needed. And what about setting up all the underlying pieces? The servers, the databases, the networks? Doing it by hand, clicking around in a web console, is slow and it's dangerous. It's so easy to make a typo, a fat finger error, or forget a step, and it's nearly impossible to perfectly replicate that same setup later on. Plus, there's no paper trail. So the modern solution is infrastructure as code. Instead of clicking buttons, you define your entire cloud environment in simple configuration files. These files can be checked into version control, reviewed by your teammates, and used to automatically and perfectly replicate your setup anywhere in the world, all with the push of a button. It is repeatable, it is reliable, and it is auditable. All right, finally, let's look at the foundational layers that make all of this stuff possible. These are the fundamental building blocks of the cloud that, honestly, we often take for granted. You see, storage in the cloud isn't just one thing. There are different tools for different jobs. First, you've got object storage. Think of this like a massive digital filing cabinet. It's perfect for storing individual files like photos, videos, and logs. Then you have block storage, which acts as the super high-speed virtual hard drive for your servers. And finally, you have databases, which are highly specialized for storing and quickly retrieving structured information, like all your user profiles or product inventories. Okay, this is a really critical distinction that people mix up all the time: availability versus durability. Availability answers the question, is my app online and reachable by users right now? Durability, on the other hand, asks a totally different question. If a disaster happens, is my data safe from being lost forever? You can definitely have one without the other. So how do we guarantee high availability? Well, we use something called availability zones. These aren't just server racks. They are physically distinct data centers, miles apart, with their own independent power, their own cooling, their own networking. By running copies of your application across multiple zones, you can literally survive an entire data center going offline from a fire or a flood, and your users would never even notice. And wrapping all of this, the final layer is your own private cloud network. Think of the entire public cloud as a giant apartment building. Your cloud network is your own secure apartment with locked doors. It's your private, isolated slice of the cloud where all your resources live, completely walled off from every other customer by default. And that's the journey from a single server struggling to keep up with viral traffic all the way to a globally distributed, self-healing, and fully automated system. By understanding these core concepts, you move from just using the cloud to truly leveraging its power. So the only question left is, what will you build with it?